going to look at some divisibility rules. So this is some patterns that you'll find to see if a composite is divisible by another number. It doesn't have to be a prime number, just any number. So we have a list here of natural numbers. I skipped some. I do know how to count. I did skip the number 7. I did skip 11, 13, right? So number 1, I didn't include some of those. Because the divisibility rules for those numbers are actually very complicated. 11 is not terrible if it's like a 2 or 3 digit number, but after that it gets a little bit more complicated. But the rest of these, actually, the divisibility rules are fairly quick to utilize. So let's take a look at this. What we're trying to do here, then, again, just to repeat, or to clarify, is to make sure to test whether or not a composite number is divisible by 2 or 3 or 4 or 5 or so forth. Okay. Now 2 is probably the most basic. Actually, no, that's not true. I think 10 is the most basic. Let's just start with that. I think that's probably the easiest one to work with. A number is divisible by 10 if it ends in a 0, right? Because any multiple of 10 just tacks a 0 on at the end, right? 14 times 10 is 140. So you tack on a 0, right? Anytime you multiply by 10, you just tack a 0 onto whatever the first number was. So every number that ends in a 0 must be divisible by 10, right? So that's it for that divisibility rule. It's really, I think, the easiest one is if it ends in a 0, it's divisible by 10. So the test there is going to be ends in a 0. Now, this is not a complete sentence, so I shouldn't capitalize probably. Ends in a 0. If it ends in a 0, if there's a 0 in the ones place, it's divisible by 10. 5 is the next easiest, in my opinion, because multiples of 5, 10, 15, 20, 25, 30, 35, 40, and so on, always end in a 5 or a 0, okay? So it's similar to the 10, but you just add the 5 in. So in the ones place. So it ends in a 0 or 5. Okay? So the ones place would either be a 0 or a 5. After that, I think dividing by 2 is the easiest one, or determining divisibility by 2. Because with even numbers, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on, the ones place will always be a 2, 4, 6, 8, or 0. I almost said 10. 2, 4, 6, 8, or 0. And so that's the test for divisibility by 2. And really the 2 and the 5 are nice like that with determining the ones place, because they're divisors of 10 itself, which was already nice. So you have this cyclical pattern to the multiples of 2 and the multiples of 5, right? So the cyclical pattern for 5 is 5, 0, 5, 0, 5, 0. For 2, it's 0, 2, 4, 6, 8, 0, 2, 4, 6, 8, da da da. So with 2, they ends in a 0, 2, 4, 6, or 8. So as long as the ones place has a 0, 2, 4, 6, or 8 in it, it will be divisible by 2. Those numbers are what we call even numbers. Okay, so those numbers are even numbers. Anything divisible by 2. Okay, let's look at 4. 4 is going to be sort of similar. Basically, 4 divides all of the powers of 10 except for 10 itself. Okay, so if you think about that for a minute, 4 divides 100, right? 4 quarters is 100. 4 times 25 is 100. 4 divides 1,000, it's 4 times 250. 4 divides 10,000, 100,000. 4 divides all of those. So if you have a big number like 2, 8, 6, 5, 7, 3, 4, 2, 8, something like that, from the hundreds place on, if you just filled in with zeros there, 4 will divide it, guaranteed. If you filled in with zeros there, 4 will divide everything else because it divides 100, divides 1,000, divides 10,000, divides everything else, all those digits. And so really all you need to check are the last 2 digits. As long as the last 2 digits are divisible by 4, then the whole thing is divisible by 4. But if the last 2 digits are not, then it won't be. Then the remainder won't be 0. Okay? So you really only need to check those last 2 digits. So with 4, we say the last 2 digits are divisible by 4. Okay, as long as that's the case, then you'll have a number, a composite number that's divisible by 4. The one I just wrote up there that ended in 28 is divisible by 4. 52,373,172 is divisible by 4. How do I know? Because 72 is divisible by 4. Okay? As soon as I know that the last two digits, the ones place and the tens place, are divisible by 4, I know the whole number is. Okay? So 4 is just a really nice one there. So I think that's probably the next easiest one to check. Number 8. The number 8 is actually very similar because 8 divides all the powers of 10 greater than 1,000, or greater than or equal to 1,000, right? It doesn't divide 100 evenly, and it doesn't divide 10 evenly, but it does divide 1,000 and on. So multiples of those as well. So you, instead of having to just check the last 2 digits with the number 8, you actually have to check the last 3 digits. Everything in the ones, tens, and hundreds place has to be divisible by 8. So if the last 3 digits are divisible by 8, all right, then you have a composite that's divisible by 8. So just a quick example, if I wrote out, I don't know, some big number like 73,205,671,836, and I wanted to determine if this thing was divisible by 8, well, who wants to do a longhand division with that thing, right? Or even punch that in a calculator. But what you can do is just take the last 3 digits, 836, divide those by 8, and as long as that is divisible by 8, then we know the whole thing will be, okay? So 8 goes into 8 once. 1 times 8 is 8. Oh, remainder 0. And then bring down the 3, of course, that's a 0, times 8 is 0. Bring down the 6, I could have just done 36 in one shot. 8 goes into 36 4 times, but not evenly. 4 times 8 is 32, remainder is 4, okay? So, so it's not 0, remainder is not 0, so 8 does not divide the entire number, right? If it doesn't divide the last 3 digits, it doesn't divide the entire number. And we would say that 8 does not divide 73,205,671,836. Okay, that is the case. So that's an example of how we would use that test. Okay. Let's jump to the number 3. Okay, I like the number 3 as well. In fact, that's one that I use very often. Because the number 3 is one of our smaller and more common factors. The trick with the number 3, and I'm not going to go through and describe exactly why this works, but the trick with the number 3 is if you add up all the digits in the number and then the sum is divisible by 3, then the whole number is divisible by 3. It's a weird result, weird phenomenon, but it works. So for instance, if you had the number 1,200 281, for instance, I add up the digits. So 1 plus 2 is 3, plus 8 is 11, plus 1 is 12, right? So you add those up, plus equals 12. 12 I know is divisible by 3, therefore the whole thing is divisible by 3. Okay, so you got to be careful. This works for the number 3. It doesn't work for any of these other ones that we've already talked about. It works for the number 3. Okay, so the sum of the digits is divisible by 3. So as long as the sum of the digits is divisible by 3, then the original composite number is as well. So we would say that 3 divides 1281, okay? Because the sum of the digits is divisible by 3. And that's nice. We can do that for long strings of numbers as well. And what's really cool is if I got a number here that I didn't really know, you could add those digits up, right? 1 plus 2 is equal also to 3. And then I know I've got divisibility by 3, okay? And so if I had something really, really big in there, I don't know, 7, 2, 8, 0, 4, 6, 3, 0, 8, 5, something like this. If I didn't, if I add all those up, this is 10, 17, 20, 30, 8, 43. If I didn't know whether the 43 was divisible by 3 or not, then I just add those digits up. And that's 7. Well, 7 is not divisible by 3, so the original number is not divisible by 3. You actually can kind of continuously break this down until you get a number that you know what to do with in terms of 3. Okay, so here 3 does not divide that number. Okay, so okay, so anyway, that's the number 3. The number 6 needs to be both divisible by 3 and even. Must be even, right? So 6 is the product of 2 and 3. So if 6 divides a number, then both 2 and 3 have to. So it's really a combination of these two rules in one. All right, so so the number is even, and so even meaning it ends in a 0, 2, 4, 6, 8, and the sum of its digits is divisible by 3. Okay, so it has to have both conditions. Okay, number 9. The number 9 is also interesting, very similar to the number 3, because the number 9 works out the sum of the digits. If it's divisible by 9, then the number is divisible by 9, okay? So the sum of the digits is divisible by 9. Then you have a number that is also divisible by 9. An example of that might be 8,400, no comma after that, 8,460, 8,469. That might work. Let's see. If I were to add digits together, 4 and 6 is 10, 18, 27, right? So if I add these together, the answer is 27. 27 is divisible by 9, and so the whole number is divisible by 9. 9 divides 8,469. Okay. So that's our test for 9. And then 12. 12 is a combination of both 4 and 3, and so it has to be divisible by 3, meaning it's the sum of its terms or the sum of its digits is divisible by 3, and also the last two numbers must be divisible by 4. So it has to have both of those conditions. So instead of writing out both those lists, I'll just say must be divisible by 3 and 4, okay? And so you just have to apply both of those rules to the number 12. Again, I said the number 7 has some rules, but they're complicated. We're not going to worry about those. The number, let's see, 7, the number 11, obviously if the digits are repeated, like 77, it's divisible by 11. If you get into 3-digit numbers, the number 11 is kind of nice because you get the outer numbers add up to the inner number, if I'm remembering that right, like the number 231, right? Because the 2 and the 1 add up to the 3 in the middle. So with 3-digit numbers, that works okay, but after that, the rule gets a little bit fuzzy. There are some nice rules there with 11, but maybe beyond the scope of what we're going to talk about. So anyway, so these are some nice divisibility rules. And then, of course, if I just had a number and I wanted to figure out what is divisible by, so if I throw the number 6,287 up there, and I want to figure out what it's divisible by, well, first of all, I look at the number 2. Does that number end in a 0, 2, 4, 6, or 8? No. So 2 is out. Okay, I'll put X's if they're out, I'll put check marks if they're in. Let's do that. The number 3, so does the sum of the digits divisible by 3? Well, this is 8 and 8 is 16, and 7 is 23. No, right? So you add those digits up, you get 23, it's not divisible by 3. If it's not divisible by 2 and 3, it ain't going to be divisible by 6. If it's not divisible by 3, it can't be divisible by 12. It also can't be divisible by 9, right? So as soon as you know it's not divisible by 2, it can't be divisible by any multiple of 2 either, right? If it was divisible by 4, it would have had to have been divisible by 2. So 6 also won't work, 8 immediately won't work, 10 immediately won't work. So the only other thing I have to check is 5 on this list. Does it end in a 5 or 0? No. Done. It's not divisible by any of these. Is it divisible by anything? At that point, I would just start long dividing or punching in the calculator. You try 7. Does 7 work? So some of the ones that I skip, you just have to work them out longhand, right? Does 7 go into this? Well, 7 into 62 would be 8 times. 8 times 7 is 56. That's a remainder of 6. Bring down the 8. 7 goes into 68 9 times. It's 63. That'd be a remainder of 5. Bring down the 7. 7 does not evenly divide 57, so no. 7 doesn't work. I could try 11. Just based on what I know about the rules. Did I just erase the number? I did. Oh well. Based on what I know about the rules of 11, I don't believe it's going to work there. But you're just checking them at that point. Okay. This one, I'm not sure that it's prime. I'm not willing to say that yet because there's a lot of other numbers that we could check. But really, we've got to check numbers. 7 won't work. 11 won't work. So then you're looking at 13. You're looking at they got to be prime numbers from here on out that are, or numbers that are not divisible by anything else we've seen. So 13, 17, maybe we could check 17, we could check 19, we could check 23. I don't know if any of those are going to work, but I'm not going to test them all right now. Okay. Anyway, that's just a trick, some ways to do that. Let's try one more. Let's try the number 21,702. All right, 21,702. So again, we'll run through these one at a time. Is it divisible by 2? Certainly, the last digit is even, right? So check mark there. Is it divisible by 3? Well, let's add them all up. 2 plus 1 is 3, plus 7 is 10, plus 2 is 12. Is 12 divisible by 3? Yes. Then the original number is divisible by 3. 2 and 3 imply then that 6 is also divisible by 3, right? It's even and the last, or the sum of the digits is 3. Let's try 4. If we go to the last 2 digits, the 0, 2 is 2 divisible by 4? No, unfortunately. So 4 doesn't work. If 4 doesn't work, then I immediately know that 8 and 12 won't work, okay? Let's try the number 5. Does 5 work? Well, it ends in a 2, not a 5 or 0, so no. Which means 10 also won't work. 9 is the last one to check. Now when we added this up, we came up with a 12, right? With the digits, that's not divisible by 9. So 9 does not work. So it is divisible by 2 and 3 and 6, but none of the other ones on this list. It is divisible by other numbers. They're bigger than 12, okay? We could also try 7, we could try 11. I'm not going to worry about that because remember, those you just have to do the long way, all right? Anyway, just some examples of how you could write that out. Now, of course, notationally, you could say that 2 divides that number. You could say that 3 divides that number, 6 divides that number.